All right, welcome. Let's see now one of the most important functions of the plasma membrane, that is controlling what can go through it or not. Here you have a plasma membrane and some ions inside and outside. Because the membrane has selective permeability, some ions can move across more easily than others. This way, ions that move slowly through the membrane get concentrated either side and create what we call a concentration gradient. Positive ions tend to concentrate outside the membrane, while negative ions concentrate inside. This is going to create an electrical gradient, meaning that the positive ions outside are constantly pushing to move inside and vice versa. Because they can't move freely, an electrical difference exists between the inside and the outside, and this will create what we call a membrane potential. Right? All cells have a membrane potential, although there are cells like the neuron that have a greater membrane potential because they are specialized in transmitting electrical signals, inputs and outputs. So ions and molecules push to move where the concentration is lower, and electrically charged ions and molecules also push to move where the electrical charge is the opposite. Both gradients together create what we call a combined electrochemical gradient. When a substance moves through a membrane pushed by its concentration or electrical gradient, it uses its own kinetic energy. So it doesn't consume the cell's energy that that normally is in the form of ATP, and this is why we call it passive transport. If a substance needs to be transported to where there is a higher concentration or the same electrical sign, then energy is required to pump the substance, and this is why we call it active transport. Here you have a molecule of ATP, and you know that the ATP is the most common way of energy storage and trade in the cell. What is that energy? Well, ATP is adenosine 3-phosphate, meaning that there is 3 phosphates. Okay, every chemical link of phosphate has energy that when you break it, that energy is liberated and it can be used for different processes. All right. So then ATP will transform in ADP from 3 to D phosphate. All right, passive transport is based on diffusion, which is a basic physics concept, and we will review this so you understand. So, diffusion is a passive process where particles tend to randomly and equally distribute in a given solution. This happens because particles in a solution move and collide constantly in all directions due to their kinetic energy. All right, so they are moving, they are colliding, they are going everywhere. Being semi-permeable, membranes have channels through which particles can diffuse, as you see, in this movie playing now. How fast they do so depends on the 5 factors you see in this list. For instance, at higher temperatures, particles diffuse faster because they have higher kinetic energy coming from the heat, and they move and collide faster, so the odds of going through a pore is increased. Okay, for instance, if you see it in water, just in water, when you boil water, you see the water moving faster, right? So the particles are colliding faster than in cold water or in ice, where they move very little. In the same sense, in high concentrations, particles, because they are concentrated, they collide more frequently, and inversely, the higher mass of a particle, the less it diffuses through a membrane, because the membrane has those channels and it's more difficult for a great mass to go through. Non-polar and hydrophobic molecules can diffuse freely through the lipid bilayer. You have, as example, oxygen, which is, and carbon dioxide also. They are very, very small. On the other hand, fat soluble molecules like vitamin A and D can also make their way through the membrane, but because a different reason. Is because the membrane is basically fat. You know, it's made of phospholipids mainly. So they can dissolve easily in those phospholipids and make their way through the membrane. And the same happens with very small molecules like water, although water is polar, but it's very small, so it moves very easily through the membrane. Membranes have channels for hydrophilic ions like potassium chloride, sodium, or calcium. Ions moving directly through the lipid bilayer do it faster than those using those ion channels, because the available surface of the membrane is enormous compared to that of the one offered by channels. Another important concept to understand the cell-water balance is osmosis. This phenomenon explains how water tends to move through a selective membrane from the diluted side to the more concentrated side when the solute can't move across the membrane. So if the solute doesn't go through, it's the water that is going through the membrane to dissolve the other side. So water can pass through the lipid bilayer and can use protein channels to go through it as a facilitated way, and those channels are known as aquaporins. The concept of osmotic pressure of a solution is the pressure due to the water pushing to move from the diluted side to the concentrated side, and it is proportional to the concentration of the solute particles at the other side that can't move. Normally, the inside osmotic pressure of the cell is the same than the outside, all right? So the volume of the cell doesn't change. In other words, the word we use technically is the inside out and outside are isotonic. Here we have a concentration solution of 0.9% of sodium chloride, which is common salt. And this concentration is considered isotonic. If you have a concentration of only 0.2%, then we say it is hypotonic. And if we have a 2% then of salt, then we say it is hypertonic. What would happen to the water content of a cell if you drink seawater, for instance? Imagine you are in a boat in the middle of the ocean with no sweet water, okay? Would you drink water from the sea? What happens to you if you do so? All right, so if you drink salty water, you get dehydration, and finally, if you keep on doing so, you'll die, because salty water is going to remove the water inside your cells. The opposite would happen if while sweating a lot, for instance, doing, I don't know, running a marathon, you drink pure water. Okay, because pure water will move inside of your cells, so because the solutes inside can't go out, so the water is going to move in. So they will swell and finally they will break. And this is why we say in this case there is intoxication with water. Some solutes are too big or are too polar to make it through the lipid bilayer or the protein channels, even if a concentration gradient is pushing them to do so. These substances use what we call facilitated diffusion, meaning they bind to a transporter that facilitates the passage to the other side. The problem is that those transporters have a limited capacity, and we call that technically they can get saturated. For certain molecules, the permeability of the membrane can be adjusted when needed. Transport of high concentrations of glucose after a meal from the blood into the cell is a good example of adjustable facilitated diffusion. When blood glucose is high, insulin is released from the pancreas and it attaches to insulin receptors in the plasma membrane of cells. This in turn will trigger that many glucose transporters are built and inserted in the membrane, so glucose can enter the cell for its concentration gradient. All right, so it's facilitated. It's not using energy. All right. In the following video, we will review active transport, whose difference with passive is that it consumes energy, normally ATP. So, although there is other ways of energy. See you there in a while.